Please be reminded of our confidentiality notice that this content contains confidential information and intended only for the St. Alicia's College Integrated School Department learners to whom it is addressed. Any review, dissemination, or copying of this content by anyone other than the intended recipients is strictly prohibited. So once again, good morning everyone and a pleasant election day. Welcome to our subject physical science with teacher Kathy. So I know I've not able to meet you for the orientation, but before we get to our two topics for this morning, let me know or kindly know your subject. So physical science, this is the course description of the physical science. It is the evolution of our understanding of matter, motion, electricity, magnetism, light, and the universe from ancient times to the present. This is also the applications of physics and chemistry concepts in contexts such as atmospheric phenomena, cosmology, astronomy, vision, medical instrumentation, space technology, drugs, sources of energy, pollution and recycling, fitness and health, and cosmetics. In short, this particular subject would help you or would introduce some of the chemistry topics and some of the physical science or let's say physics topics. So this particular it is called physical science because it deals more of the concepts related in our matter or anything that has mass and volume or occupy space and motion as well. So this particular subject would help you understand somehow some of the concepts in both chemistry and physics. Take note that in your strand, in general academic strand, physical science is a specialized subject. So the same grading system, we have written works that is 40% of your grade and your performance test or the activities that you have answered is 60%. So in the topic outline of the physical science, these are the concepts actually that we will be discussing throughout the course or throughout the subject, such as we have here the elements formation and evolution, the properties of matter, the chemical changes, contribution of chemistry. Earth is not the center of the universe, the laws of physics, light as a waving particle, and understanding the cosmos. So these are actually the chapter titles of the topics or the yes the topics that would be discussed in this particular subject, as well as please kindly join your Quipper code, your class in Quipper with using this code and the Google Classroom using this code. Also, since this physical science is more of chemistry and is more of chemistry and physics that involves the elements in the periodic table as a requirement for this particular subject, there will be an oral recitation every meeting. So before we start with our new lesson, we will have, since you are just a few number of students in this class, so we could actually insert that particular activity before discussion, such as that there will be an oral recitation every meeting that we have before we proceed with the new lesson that to be tackled for the day. And to help you prepare in that particular oral recitation, I want you to have a periodic table of elements. You can buy it, you can actually download it and look for it in Google. So there are many available resources that you could find out. So it is the periodic table of elements. Then you are going to familiarize the name of the element, its symbol, and atomic number. For example, the first element or the lightest element in the periodic table is the hydrogen, spells as Hydrogen, with the symbol H, and its atomic number is 1. So those are the three things that you are just going to remember: the atomic number, the symbol or the name of the element, and its symbol. So for the next meeting, for our first oral recitation, you are going to familiarize the elements in the periodic table from 1 to 10, or the elements with periodic number or atomic number to 1 to 10. So that would be the first oral recitation that we are going to have. The atomic elements or the elements from 1 to 10 in the periodic table. Now, enough of the preliminaries. Let's go to our two lessons that would be the coverage of your mastery exam. So the Big Bang Theory and the formation of light elements, and stellar evolution and the formation of heavier elements. So by the way, the first topic that we are going to have, the first two topics, this is all about how do the universe was created. This is more of the cosmology. So as I mentioned, physical science is a particular subject that is more of chemistry and physics. It's a combination of chemistry and physics that would understand what is the concepts behind in our environment, in our outside world, or in our physical world. So this particular two topics is somehow would give us an idea how does celestial bodies, the stars, and how does the universe started. This is more of cosmology or astronomy. So with these particular two topics, at the end of this lesson, you would be able to somehow give evidence and explain the formation of the light elements in the Big Bang Theory, and also to give evidence for and explain the formation of heavier elements during star formation and evolution. By the way, when we talk about the stellar evolution, we are talking about how do stars form? How do stars form? So these are the things that we will be discussing this morning. So let me begin the discussion by defining what is cosmology. So, cosmology is the body of science that studies the origin, the evolution, and eventual fate of the universe. So, when we talk about cosmology, we are dealing. It is a science that deals actually with the universe, the study of the universe, particularly its origin and its evolution. So, that is cosmology. And there are religious cosmology. There are two types of cosmology, such as the religious cosmology and the physical cosmology. So, religious cosmology is explains the origin of universe and life based on religious beliefs of a specific tradition. The concept of creation ex nihilo, or the God creating the universe as written in the book of Genesis. Since again, as I mentioned, cosmology is all about the study of the universe and its origin and revolution. According to Catholic faith, the universe was created in 7 days, and that is an example of a religious cosmology. It is the explanation of how does the universe was created. So that is what we know as religious cosmology in the concept of creation ex nihilo and written in the Bible in the Genesis. And there is also a physical cosmology. So it explains the origin of the universe based on scientific insights, studies, and experiments. So it was Copernicus and the heliocentric nature of the universe, the expanding universe to Albert Einstein's theory and the Big Bang theory. So in physical cosmology, on the other hand, this is more of facts, this is more of scientific insights, studies, and experiments conducted by the brilliant astronomers in our human history, such as Nicholas Copernicus, about the physical cosmos explains the origin of the universe through his theory, through his theory, the heliocentric nature, and the Albert Einstein's expanding universe as well, or the theory of relativity. So, and also the Big Bang theory. So these are the somehow the explanations are the one of the examples of the physical cosmology that would explain the origin and evolution of our universe. So, what is the commonly thing that are well known origin of the universe and somehow accepted by the scientists or the astronomers is what we know as the Big Bang theory. So, in Big Bang theory, this is a cosmological model that describes how the universe started its expansion about 13.8 billion years ago and states that the universe continues to move and expand. So, according to this theory, by the way, this is still a theory. There are some levels there are some levels in the facts or the concepts introduced in science, such as there is an hypothesis, this is an estimated guess. Then we have a theory, meaning it is a somehow this is somehow acceptable fact. This a theory is an acceptable fact, but it is not yet proven, or it is an acceptable fact or explanation over a particular event or phenomena, but somehow there are truths about it, but some also negates on the idea, so it needs to be proven yet. That is a theory. Then we have the law. So when we have the law, it is accepted already, it was proven already and agreed by the people, or agreed by the experts on the field. So that is how things are in science concepts are being discussed or being developed into different laws, theories, or theorem, and um, guesses or hypotheses. So one of the things that is an acceptable fact but somehow not yet proven is what we call the Big Bang theory. So this is the oldest theory that we have, or the accepted, well accepted um, origin of the universe, or the explanation of the how the universe started. And it actually speculates about 13.8 billion years already. That is the time that the universe was created. And according to the people, or according to the astronomers who studied this, the universe is actually expanding and expanding, or it continues to move and expand. So according to this theory, there are three things no, there are things that proves that the Big Bang Theory is the explanation how the universe started. Number one is that the universe began as a singularity, or a point containing all space, time, matter, and energy. According to this theory, the Big Bang, or the universe, started as point a single point in our celestial bodies, or in the universe, or in outer space, that is consists of space, time, matter, and energy. And it expanded rapidly in nothingness through a rapid yet peaceful process called inflation. Because of this, because of this um, singularity or a point, it continues to expand and expand without um, rapidly in nothingness, without an explainable fact that would somehow support why this point continues to expand. And this process was called inflation, the expanding, or the rapidly expanding of that point in nothingness. Then, after expanding, of course, since when you are, let's say, you are holding a dough of a bread, and if you keep on expanding or stretching it, of course, you will exert more force, you will exert more effort, thus, you will get tired. Because of that expansion, continuous expansion in nothingness, in the process of called inflation of the universe cooled down as it expanded, because it needs rest, because it puts too much effort in order for it to expand, the single point, in order for it to expand. So it cooled down. Then a soup of matter in the form of subatomic particles was formed, and nuclei of light atoms were created via nucleosynthesis, or nuclear fusion between protons and neutrons. Because of the cool down of the universe, take note that in the first step, that the universe begins with a singularity. It contains space, time, matter, and energy. Space, time, matter, and energy. So as it expands, it has actually subatomic particles. When we talk about subatomic particles, we are referring to the um, positively charged particle, the negatively charged particle, and no charged particle. Uh, Specifically, it is referred to as neutron, positron, positive, um, protons, sorry, protons, electrons, and neutrons, the subatomic particles. And these particular subatomic particles were developed because of the process nucleosynthesis or nuclear fusion. By the way, please take note of the term fusion and fission. When we talk about fusion, when we talk about fusion, this is merging of two subatomic particles. That is fusion. But when we talk about fission, when we talk about fission, it is somehow the um, explosion or separation of the particles. There's a separation of particles, that is fission. But if it is fusion, meaning it fuse, it merge, it is the nuclear fusion, the process wherein the subatomic particles were merged. So this nuclear synthesis was brought about protons and neutrons. Then the Big Bang theory, the electrons interacted with this nuclei to form actual primordial atoms via the process of recombination. So later on, I'll be introducing to you as well how this particular or how these things make sense, or how these things were able to form a particular universe in the process of the stellar formation as well, or the star formation. So since the point or the singularity of the universe as a point contains already with matter and energy, of course, it is present with the subatomic particles. So at first, the nuclear fusion, in this nuclear fusion, it was protons, the positively charged particle, and the neutron, the no charge, was actually being merged. Then the negatively charged particle called electron was um, was being processed, was being combined with other subatomic particles as well in the process of recombination. So this is the process, or this is the explanation of the Big Bang theory. How does the universe expand, or how does the universe started? This was the theory of the great scientists before us, or our, yes, the development of this theory was based from the person, or for the scientists who studied this before. So this is the explanation of the Big Bang theory. So most of the scientists was actually intrigued of this particular theory. Thus, they looked for some of the evidences that would support this particular theory. Because in science, you cannot just simply say that the weather is good, that it will be raining. You cannot just simply say that the color of the sky is blue. You cannot just simply say it, such things like that. You need to prove it. In order for you to prove something, you need to gather evidences. And these are the evidences of the explanation, or the theory, or the evidences gathered by the different scientists in order for to support the idea of the Big Bang theory as the origin of the universe. So number one, the Vestus Leaper and Carl Wilhelm Wirth. It was 1910. These are two scientists actually who agreed or contribute to the support of the Big Bang theory. According to these two scientists, there is a measurement of redshift. So later on as well in this discussion, I'll be explaining to you what is a redshift. Observe that most spiral galaxies were moving away from the Earth. Take note that according to Big Bang theory, the universe is continues to expand and expand. Thus, they noticed that the spiral galaxies were moving away from the Earth. And another thing, or another astronomer who proved it as well, or who supports the Big Bang theory, said that according to George Lemaitre, he proposed the alternative idea that the universe is expanding. So it was his idea that maybe in 1927, maybe the reason why that most spiral galaxies were moving away from the Earth is because the universe is expanding. So if you are going to imagine it, that the universe is expanding and expanding, of course, it is moving away and away from a particular reference point. So, for example, you cannot simply say if there is a tree here, if there is a tree here, then of course, and you are standing here. So you could say that this is your reference point. And later on, as you go away, this is your reference point, the tree. Okay, so as you move away from the tree, of course, you could say that that you are going farther, that you are going farther also in the tree because your tree is the reference point. This is the same idea as well with this particular scientist or astronomers. According to Sleeper and Birds, the spiral galaxies were moving away from the Earth because their reference point is the Earth. And it was Lemaitre who said that it may be the galaxies were moving away from Earth because the universe is expanding. Another astronomer said that it was Edwin Hubble in 1929. He calculated the distances between the Earth and the several galaxies using redshift of light. So he calculated the distances between the Earth and the several galaxies on using the redshift of light and observed distant galaxies were moving away from the Earth and one another. So Edwin Hubble actually supported the idea of Lemaitre when he said that maybe the universe was expanding, and also the idea of and birds and sleeper that the spiral galaxies are moving away from the Earth. So to prove the three astronomers before him that the universe is really expanding and spiral galaxies were moving away from Earth, he calculated the distances between the Earth and the several or the other galaxies using the redshift of light. Then, according to Robert Wilson, and Arno Penzias in 1965, they discovered cosmic microwave background radiation or CMBR, a low steady humming noise believed to be energy remains. Take note that the Big Bang Theory said it started with a point or singularity. It started with a point that contains matter, time, um, energy, and motion. So according to them, they heard or they discovered that there is a low, steady humming noise in the outer space, and they called it as cosmic microwave background radiation. So this is the sound of this universe as it expands because it contains energy, and sound is an energy. And according to the modern astronomy in 2014, the universe is estimated to be 13.8 billion years old, with 5% of its composition existing as ordinary matter. So according to this modern astronomy, with the contribution of the ideas of all the astronomers who have gathered to contribute or to support this theory, they said that the um, universe is estimated to be 13.8 billion years old, and that is also the so-called um, the explanation why is it said that the Big Bang theory or the universe is estimated to be 13.8 billion years old, with 5% of its composition existing as ordinary matter, because that point or singularity, or it starts with point with that singularity, contains all of the matter, the motion, the time, and energy. Because of this Big Bang theory, there exists an idea such as what we call now the Big Bang nucleosynthesis. From the word nucleo, meaning it refers to the subatomic particles. Synthesis, meaning it is the breakdown. So when we perceive Big Bang nucleosynthesis, this is the breakdown of the subatomic particles. How does this these are some of the evidences as well that would say that would support the expansion of the universe. So the Big Bang nucleosynthesis, or the BBN, also known as primordial nucleosynthesis, it is a process of producing light elements during the Big Bang expansion. So as I explained to you, the Big Bang theory, it keeps on expanding and expanding. As it expands, since there is an energy and matter present in that single point, of course, there are subatomic particles on it. And these subatomic particles are actually the origin or the composition of the elements. Thus, in the universe, or thus in the outer space, light there are light elements during the Big Bang expansion. So it yields two stable isotopes of hydrogen, two isotopes of helium, and some lithium atoms and beryllium isotopes. By the way, hydrogen, helium, lithium, and beryllium are some of the elements found in the periodic table, and they are labeled to be light elements. Why? Because their atomic mass or atomic weight is very low, such as, like, for example, hydrogen its atomic number is 1. This is the first element, and this is also the lightest, yung may pinakamagaan na element. How do we say so that it is the lightest? Because its atomic number is 1. Its atomic number is 1, and most likely its atomic mass as well is also 1. And followed after hydrogen, we have helium as well as number 2. Lithium, I think it's number 3 or 4, and as well as the beryllium. So either of these, hydrogen is 1, helium is 2. I'm not really sure with the helium and beryllium, but I think this is also the third to fifth elements in the periodic table. The third to fifth elements in the periodic table. So this is how does the element or as the universe expand, there is a nuclear fission that is happening, meaning the subatomic particles are being separated. Thus, yeah, after it was being separated, it is combining again with other subatomic particles that is also from the other processes of nuclear fission in that particular expansion. Thus, there is a merging, a nuclear fission, and a nuclear fusion that is happening. So a proton, a positively charged particle, and a neutron, N, or no charge, may fuse together to yield a high energy photon and an isotope of hydrogen called deuterium. By the way, when we talk about isotope, the this is an element, a replica of an element, but it differs only with the number of subatomic particles on it. For example, the hydrogen has an atomic number of 1. Thus, it follows that it has one proton as well, one proton or one positively charged as well in its particle. Deuterium, on the other hand, is also a hydrogen with an atomic number of 1, but its number of protons is actually 2. the number of protons is actually 2. That is what we call an isotope. And these isotopes are elements that have the same atomic mass, but they differ on this number of subatomic particles present on it. So hydrogen, the isotope of hydrogen is a deuterium with 1 proton and 1 neutron. However, in the hydrogen is consists only of 1 proton and 0 neutron. However, deuterium, in the other hand, it consists of 1 proton and 1 neutron. So this is the chemical equation, or the chemical formation of the equation. How does deuterium was formed? There is a proton and a neutron that is being added. This arrow sign is actually symbolizes the product after the fission. After the fusion, I mean. So the proton, 1 proton and 1 neutron is being added. Then there exists a deuterium, a hydrogen. As you can see, this is still H as the symbol of the hydrogen. But then the proton is actually now 2, and it is formed. This particular of formation of deuterium was brought by a gamma ray, so the deuterium bottleneck can be traced to its low binding energy and eventual destruction by photons at very high temperatures. A decrease in temperature enabled deuterium to stabilize and eventually initiate the BBN cascade. Two um, deuterium nuclei may fuse together to form either of the following. Take note that in the fusion that is happening, fission and fusion, for example, this is a subatomic particle, this is another subatomic particle, and this is another subatomic particle. It undergoes, as the universe continues to expand, it undergoes, most likely these energies are being exploded, or they are actually having the process called nuclear fission, meaning it breakdowns or separates. So from these subatomic particles, have a it separates, or let's say it was separated with a new nuclear energy. This one undergoes a nuclear fission as well, so there is a breakdown. This one as well, there is a breakdown. Then most likely, since it was breakdown already, some of the nuclear fission, or some of the elements, since it is already present in the universe, and it is being scattered away, most likely some of the particles are as well are merging from the other nuclear fission or fission processes, and some of the subatomic particles are being combined with other subatomic particles present as well on the universe. So from here, let's say this particle and this particle undergoes as well a subatomic in a nuclear fission, then maybe this product and this one is being formed again through nuclear fission, or this subatomic particle and this particle was formed another particle. This is all I agree, or this is all of these things are possible as the universe expands, and that is what the Big Bang nucleosynthesis is trying to tells us, that this is the breakdown of the formation of the different elements in the universe, such as the deuterium as the isotope of hydrogen. So when two deuterium nuclei fuse together through nuclear fusion, they either form of the following. Number one, the deuterium might have a radioactive H isotope called tritium, or the T, but there are 3 hydrogen atoms on it, or um, 3 protons on it, but its symbol, it's still letter H, as it is one of the isotope of hydrogen, with 1 proton and 2 neutrons and 1p, or the deuterium that might form is also the helium-3 or the He3, or this is the symbol for helium, with 2 proton and 1 neutron along with 1 neutron. So this is the formation. This is the formation of the tritium and the helium. So this might be the products. This might be the products of the two deuterium. So two deuterium and another deuterium, if being combined, byproduct could be another isotope of hydrogen, such as the tritium, because there is another additional proton that is being added to it, or when the two deuterium are being combined, it could have a product of a helium, and it is combined with a neutron. Then from helium, another possibility, since the deuterium is already combined, or the deuterium, when the two deuteriums are being combined, it might have a product of this, or it might have a product of helium. In case that the product of the fission is helium, it creates helium-4, or another isotope of helium, He4 or 4He with two protons and two neutrons may be formed from three fusion reactions. So this is after the formation of helium, or the possibility that after the formation of helium-3, a helium-4 might be the product of that nucleosynthesis. So it might form with, or it might have a three fusion reactions. Number one, the fusion of one proton and a tritium atom. One fusion of one proton and a neutron atom. Tritium atom, I mean. So this one, H3 plus the proton is equal to helium-4. So when according to this, when the two deuterium is being combined, a tritium might form. So when this tritium is being combined with a proton, helium-4 may arise. Helium-4 may form. Then, when another deuterium is combined with a tritium, it might also have a helium-4, another isotope of helium. Then, if a deuterium is combined with an H3, helium-3, or another helium, then it might have an helium-4 when being combined with a proton. So these are the possible byproducts, and this is how the elements are being combined in the universe as the universe expands. So this Big Bang nucleosynthesis is brought to the explosion, or the continuous expansion of the universe. And when it expands, these things happen. It forms light elements. What are the elements that might form? It might form a hydrogen, the isotopes of hydrogen, such as the deuterium and the tritium. It might also form a helium-3 or an isotope of helium, such as the helium-4. So these things are possible in the Big Bang theory, or Big Bang nucleosynthesis. And the helium-4 has a binding energy of 28 MeV, and further fusion products were a rarity, since these resulting atoms had binding energies lower than this aforementioned amount. So this particular helium-4 as an isotope of helium-3, its binding energy, or its capacity in order to have a nuclear fusion with other elements as well, or with other subatomic as well, is very rare, since the binding energy of the helium-3, of deuterium and tritium is lower than the helium-4. So as a result, this helium-4 may still undergo further fusion in the presence of the tritium atom, yielding the lithium 7 atom. So, and with yan, because of the continuous, kasi nga, mas mataas yung binding energy niya, because it has a higher binding energy compared to the previous, compared to the other elements that were mentioned. This helium 4 might combine as well to another tritium and hydrogen, this one, a hydrogen with three subatomic particles. So when it is being combined to lithium 4, it might to helium 3, helium 4, I mean, it might have a new element such as the lithium 7, and it is a product by a gamma ray. But when this lithium 7 is being added with a proton, it might have two helium or two helium 4 that is being combined. And this is the byproduct as we break down this lithium 7. Then the helium 4 may also fuse with another helium 3. Then it is now the beryllium 7, the unstable isotope of beryllium 7, this one. Again. So I hope you were able to somehow grasp the idea how does the subatomic particles are being combined from one element to another element, in order for them to create light elements that is present in the universe, or yes, that is present in the universe. So we have now the beryllium 7, as the He or the helium 4 is being combined with a helium 3. So the nuclear reactions predicted by the Big Bang nucleosynthesis. So as you can see, when a neutron is combined with a proton, a deuterium is being formed. Again, when a neutron combined with a hydrogen, a hydrogen begins with a neutron and a combined with a proton, it forms a isotope of hydrogen, which is the deuterium. And this deuterium, when being combined with another proton or with another proton, it forms another isotope of hydrogen, now called as uh, tritium. But when this deuterium is added by a neutron, a helium 3 is being produced. So when this helium 3 is added by a proton, it forms a helium 4. But when the helium 3 is added with another proton and a neutron, it forms a tritium. And when this tritium is added by a neutron, it forms a helium 4. But when this tritium is being added with a helium 4, it forms a lithium 7. But this helium 4, when being added with a proton, it forms a lithium 7. When this helium 3 is added by a helium 4, it forms a beryllium 7. But this beryllium 7, when added by a proton, it forms a lithium 7. So this is how the light elements in the universe are being connected, or how this is the formation of the light elements in the universe as it continues to expand and expand. So the correlation between predicted and reserved cosmic abundances of the hydrogen and helium was the major proof of the Big Bang theory, because at its as the universe keeps on expanding and expanding, there is helium and hydrogen that is being formed in the universe, or the elements are being formed in the universe. Thus, it continues to support, or it continues to give us as the major proof of the Big Bang theory. Almost all available neutrons have combined with protons, forming 24% of the He4, by mass, and about 74% of hydrogen by mass remained uncombined in the universe. So this is the um, one of the major proof of the uh, existence or the history or development of the universe because of the presence of the light elements of hydrogen and helium in the universe. To verify this observation, scientists measured the abundances of primordial material in unprocessed gas in some parts of the universe with no stars, as well as in parts of the meteorites known as chondrites that commonly fall to Earth. So these chondrites are actually the meteorites that we see as a falling star. We see as a falling star in our Earth. So in order for to provide or to verify observations, scientists measure the um, unprocessed gas in some parts of the universe that has no star actually, and the result is that did not this Big Bang nucleosynthesis did not give rise to elements heavier than beryllium. So meaning to say, as the universe as the universe expands and as the subatomic particles are combined to be to different subatomic particles as well as the formation of the elements, the higher possible um, element that could be combined is only beryllium with a subatomic particle of, atomic number of 7. And this is the lightest, one of the lightest element known in the periodic table. This means that there is a drop in temperature resulting in insufficient levels for fusion reactions to push through. In order for a subatomic particle to be combined with another subatomic particle, it requires high energy. But since there is an insufficient energy, there is no the possibility of the beryllium to combine with other subatomic particles, whether a neutron or a neutron or a proton, is not anymore possible because of insufficient energy levels. And nucleosynthesis continued with the expansion of the universe. Imagine how many hydrogen and helium, or how many protons and neutrons are being scattered in the universe, and they are being combined to each other and each other, forming many hydrogens, forming many deuteriums, forming many tritiums, forming many helium-3 and helium-4, forming um, forming lithium-7 and beryllium-7 in the universe. And the highest, or the highest in weight of the light elements is only beryllium, because it cannot combine anymore to either proton or neutron because of insufficient levels. So that's the Big Bang nucleosynthesis, or the Big Bang theory, that explains how does the light elements are being formed. However, on the other hand, it says that in the Big Bang theory, only beryllium could be the last element that the expansion of the universe could actually form. Only beryllium. But then there is another similar study, but not in the universe, but more focused on the stars. And this is actually what we call now as the stellar formation. So when we talk about stellar formation, this is the star formation. This is the star formation. So the star formation theory states that stars form when gravity acted on the particles expanding with the universe. So as take note that the lightest element, or the highest element that could uh, that could be formed in the Big Bang nucleosynthesis, is the beryllium. But when this particular element, the beryllium, is being acted with a gravity, stars are being formed. And this formation of the stars is what we call now as the stellar formation. This is the theory that explains how stars are formed. So stellar nurseries from the dense molecular regions and photostars are formed when these regions collapse. So the stellar nucleosynthesis, the elements associated with both living and non-living things mostly originated from stars. That's why there are quotes or I I don't know if you were able to read this particular quotes that there is a person or a philosopher said that all things are that we are from stars, that all living things, that all living and non-living things are from stars. And this is what he meant by this, that the elements that are present in our body as living and the non-living things around us are actually found in the stars, are found in the stars. So technically, they can say that all of us, both living and non-living things, are from stars, or originated from stars. So processes that occurred inside stars were responsible for the formation of these elements. And elements heavier than beryllium were formed through nuclear to stellar nucleosynthesis. So take note, as I mentioned, as the universe expands, it forms light elements. And the heaviest among the light elements is the beryllium. But then this beryllium could actually be more heavier when a star is being formed. That is through the process of stellar nucleosynthesis. The helium and the hydrogen and the helium produced from the Big Bang nucleosynthesis started to combine in nuclear fusion reactions. Because of the combination or the fusion of the helium and of hydrogen and helium, beryllium, and lithium was being formed, and very high amounts of energy were released in the form of light, heat, and radiation. As it forms, it takes a lot of energy. It takes a lot of energy as the subatomic particles or elements are being combined in the process of nuclear fusion. But it is greater much needed energy for this particular element to explode or to undergo fission. So it requires very high amounts of energy for the elements to um, explode or to separate. So the stellar evolution refers to the process in which a star changes through its lifetime. So, as you can see, or as you all know, there are different levels of stars. The levels of stars, the levels and sizes of stars are actually based from the number of elements, the abundances of elements that are being combined to that particular star. It still continues to change as it evolves, and the biggest star among all of them is what we know as the sun. And the course of evolution is determined by its mass. And all stars are formed from stellar nurseries called nebulae, and a nebula breaks into smaller fragments as it further collapses before contracting into a protostar, or a very hot stellar core that continues to gather gas and dust as it contracts and increases in temperature. So take note that stars are being formed. Again, stars are formed. Take note that the stars are formed when the nuclear fission and nuclear fusion happens. not only the subatomic particles are present in the universe, but as well as there are nebulae. They are the stellar nurseries. So when, for example, when there are subatomic particles in the universe, such as like this, there is a nebulae that is actually present in the universe that also attracts or merging some of the scattered particles. Thus, when it um, merge, as it gathers some of the subatomic particles that are scattered in the universe, a star is being formed. And the lowest form of the formation of the star is what we call now the protostar, or a very hot stellar core that continues to gather gas and thus as it contracts and increases in temperature. Since these subatomic particles contains energy, and by the way, energy and temperature are related to each other in a sense that as the temperature rises, its energy is also rising. So when these particular subatomic particles are being gathered by the nebulae of the core, then this contains energy. Thus, the core or the nebulae also increases its temperature and its energy level because it merges some of the energies as well in the subatomic particles. Then, nuclear reactions like the proton-proton fusion reactions occur at temperature of around 10 million Kelvin. And the protostars evolved into main sequence stars upon reaching gravitational equilibrium. Nuclear reactions form subatomic particles called neutrinos and positons. Nuclear reactions form subatomic particles called neutrinos and positons. An increase in pressure both brought about by positons and neutrinos halt the contraction of the protostar. By the way, this neutrinos is different from neutron. Positons is different from protons. Okay. Then the sun is believed to be the middle of the main sequence phase of the stellar evolution. Sun is actually a star. Okay. So the sun says that it will remain as such for at least 5 billion years. And take note that the universe has an estimated of 13.8 billion years old. And according to the scientists, still the sun will be present by 5 billion years. It will live until 5 billion years. So the red dwarf stars stay on the main sequence phase for at least 100 billion years due to the slow rate of hydrogen fusion. So the red dwarf, the first formation of the, okay, how do stars form? It begins with the nebulae or the core that is actually gathering gas and dust in the universe. Particularly this gas and dust that I am referring to are the subatomic particles. When this nebulae gathered much of the dust and the subatomic particles that are scattered in the universe, it begins to form a protostar. And this protostar, as it continues to gather and gather more, it becomes a red dwarf star. Red dwarf star. And this red dwarf star is going to last until 100 billion years due to the slow rate of hydrogen fusion. Because as the star as the star evolves, it also requires a high level or a higher more level or a more level of subatomic particles. In such case, the red dwarf stars need hydrogen need hydrogen to gather in order for it to develop. And since there are a lot of subatomic particles, there are also a lot of possibilities that these hydrogens are being formed with other subatomic particles. Thus, it somehow there is a deficit of the hydrogen fusion in the universe. But take note that as the universe expands, the subatomic particles are being abundant as well in the universe. Then after the red dwarf star, there is a brown dwarf star. So not all photostars become main sequence stars. Take note from the photostar as it gathers much of the gases and dust already in the universe, it begins to form a red dwarf star. But not all photostars become a red dwarf star. Some of them becomes a brown dwarf stars that are only able to fuel deuterium fusion reactions. Take note that the red dwarf star requires hydrogen fusion, but then brown dwarf stars require deuterium fusion. Then they cool gradually have an average lifespan of less than 5 billion years. Then the main sequence stars evolve into red giant stars when all hydrogen atoms in the core gets depleted. So from the red dwarf star, it will form into a red giant star. So again from the red dwarf star, it will as it gathers much of the hydrogen, it becomes a red giant star. But when hydrogen atoms are being depleted, meaning it is lacking or not enough already for the red giant star to absorb, helium becomes the major component of the core instead of the hydrogen. So proton-proton chain reactions use hydrogen to produce helium because the red dwarf star gathers hydrogen and hydrogen, there are no or the hydrogens are being depleted in the universe. Since it is already depleted and that star evolved into a red giant star, the hydrogen that is being absorbed or gathered undergo a proton-proton chain reaction producing helium because red giant stars needs helium to evolve into a higher level star. So hydrogen fusion moves to the outer shell and the core surface. Then from this, fusion stops when all hydrogen atoms in the core are used up. So take note the red dwarf star contains more of the hydrogen. So whereas it contains or gathered much of the hydrogen, it promotes or it evolves into a red giant star. And red giant star needs helium. So when there is no hydrogen available already in the universe to absorb, they create or they undergo a proton-proton reaction and produces helium. But there would be a time that the hydrogen that is being absorbed, that is converted into helium, is no longer available. So when all hydrogen atoms in the core are used up, the fusion stops inside the red giant star. And the pressure in the core decreases because it needs more and it needs helium, but then there are no helium available anymore to absorb. So helium atoms or particles are converted to carbon via the alpha fusion processes. The helium atoms, that is the product of the proton-proton nucleosynthesis, is converted into carbon by the alpha fusion processes. Then the temperature can increase to approximately 10 million Kelvin because of the depletion of the hydrogen present in the universe. Then the pressure also increases. The hydrogen is pushed away from the core. Then the resulting expansion eventually transforms the main sequence star to a red giant star. So for you to better understand this is how the uh, composition of a red giant star. So the main sequence stars evolve into red giant stars when all hydrogen atoms in the cores get depleted. So take note that the yellow is the inert hydrogen, the hydrogen fusion is the red one, the helium fusion is the blue one, and the inert carbon is the green one, and the inert carbon. So the red dwarf star, take note, red dwarf star requires hydrogen. So in order for a red dwarf star to evolve into red giant star, it needs much of the hydrogen. So this hydrogen, the yellow part, will be converted into helium, and that is the process called the hydrogen fusion, and the green one there is actually down the fusion, and the helium is being converted into carbon, and that is now the blue one. So the low mass stars turn into white dwarf stars when the majority of helium in the cores are consumed. Take note from the red dwarf star to red giant star, but when the cores are consumed, when the helium in the cores are consumed in this particular illustration, when the green one here are being consumed already in the inner carbon, a white dwarf star is being formed. So from the white dwarf star, the hot and inert carbon core eventually becomes the white dwarf. The lower amounts of helium in the core decrease the rate of alpha processes. Outer shell expand into space, forming a planetary nebula. So, as the red giant, or as the helium that is being consumed, converted into carbon, that particular inert carbon is becoming a white dwarf star. And the lower amounts of helium in the core, in the inert carbon, will decrease also the alpha processes. And the white dwarf's composition depends on its predecessor's mass. A sun-sized main sequence star lacks energy to fuse carbon, and white dwarf would mostly contain inert carbon and some oxygen. So take note that in the illustration earlier, or from the previous slide, so from the inert carbon, it needs to consume helium. So when the helium is being also depleted in the uh, universe, or not enough helium as it consumes, this white dwarf star contains already oxygen. It needs a lot, of course, for the star to evolve, it needs a lot of energy. How to gain the energy? It needs to consume more of the elements, more of the subatomic particles. So, but when sometimes those things do not acquire more, so this carbon, the inert carbon, turns into oxygen, and a smaller star will produce and a smaller star will produce a white dwarf mostly composed of helium and a bit of hydrogen. So a smaller star will produce a white dwarf mostly composed of helium and a bit of hydrogen. Because it is not enough already helium, that there is no enough, or the depleted helium already, there is a depletion of helium already, so the smaller star, or the white dwarf star, is composed mostly of helium and hydrogen, because it absorbs from hydrogen then turns into helium. Then massive stars evolve into multiple shell red giant stars. So a high mass star can reach pressure and temperature levels favorable for carbon fusion. It evolves through several stages where heavier elements are fused in the core and in the shells around it, eventually forming multiple shells. So the multiple elements form in a series of reactions in the following order: from the carbon to oxygen to neon to silicon and to iron. And this is because of the formation of the stars. This brought up how the heavier elements are being formed as well in the universe. This is the explanation why there are heavy elements that are found in the universe. So from the carbon, let's go back to the illustration. Where is it? So from the carbon, so from the oxygen and from the hydrogen, in order to form a star, it needs a lot more of hydrogen. Then hydrogen, it will combine, will undergo a photon synthesis. It will create helium. Then from helium, it will create into carbon. And when this carbon absorb helium, it will create oxygen. And uh, when this oxygen is being combined with more of carbon and helium, it will create neon. And this, when neon combined with oxygen and more of carbon and helium, it will turn into neon. And this neon will turn into silicon and to iron. And this is how the heavier elements are found in the universe. And the elements lighter than iron can be fused since the nucleus produces a mass lower than the sum of their masses. So from the iron, it could be a silicon and silicon, then form into iron. It could be neon to silicon that is being combined to each other and form into iron. So those elements that is lighter than the iron can also be formed to create an ion. So the stellar nuclear missing mass is released as energy. Stellar nuclear synthesis of elements heavier than iron is not possible due to its energy requirement. So the heaviest element that is found in the universe is the iron, and it cannot be combined anymore with a much heavier element because it requires again a lot of energy. It requires a lot of energy. And because there are a lot of nuclear fission and fusion that is happening, of course, there is a scarcity or depletion of energy as well from the subatomic particles. And massive stars evolve into multiple shell-red giant stars. And this is how does the star or the multiple shell-red giant star is being formed um, with the different elements that are being absorbed. So the stellar evolution, elements heavier than iron are formed in after a supernova. So from take note again, let's trace the stellar evolution from the nebula, to protostar, from protostar to red dwarf star, and some of the red dwarf becomes a brown dwarf star. From the red dwarf star, it becomes a red giant star, and from the red giant star, it becomes a white star, and from the white star, it becomes a massive star, or or a multiple shell red giant star, and from the multiple red giant star, it will now create a supernova. So an exploding multiple shell red giants, an exploding multiple shell red giant star is called a supernova. It happens when its core can no longer produce energy to resist gravity. So there is an explosion of the star. The explosion of star is possible when there is no longer sufficient energy that is being produced to sustain that particular star. Of course, when there is no enough energy anymore or no elements that is being absorbed, the tendency is that the star will undergo nuclear fission or will explode, and its subatomic particles that are being consumed as well by other stars. So it releases massive quantities of high energy neutrinos, and the neutrinos break nucleons and release neutrons. The generated neutrons are picked up by nearby stars and key step in the formation of elements heavier than iron. Because of the multiple shell red giant star that is being exploded, a supernova is created, and when the supernova cannot hold or cannot consume sufficient energy, it will explode. And the explode when this supernova explodes, some of the neutrons or some of the elements are being consumed by the other stars or nearby stars. And this is the reason why there are elements heavier than iron is also being formed. So this is the reason, or these are the evidence why we say that there is really a stellar evolution, or how can we say that is, or these are the things, or these are the proof that there is there is such thing as stellar evolution. So number one, the discovery of interstellar gas and dust in the early 90s. The study of different stages of stellar evolution happening throughout the universe, and the infrared radiation, or the IR, can be detected from different stages of stellar evolution. The release by photostar is measured and compared to IR from nearby area with zero extinction, and approximation of energy, temperature, and pressure from the IR, so from the infrared radiation. So this proves these are the evidences that stellar formation is really possible. It happens when the astronomers notice that there are different stages of stellar evolution, and of course, from the looks of the star as well, they are wondering how does this particular star looks like this. Why is it is smaller in size, bigger in size? So they need to prove it. How they were able to say that it is already evolution, or it is already transforming from one form to another, of course through the infrared radiation. So those are the things that was able to that the two topics, the Big Bang theory actually, and the stellar formation. So these are the key points that that was being discussed. Key points is that number one, the Big Bang Theory is a cosmological model that describes how the universe started its expansion about 13.8 billion years ago. And Big Bang nucleosynthesis is the process of producing light elements during the Big Bang expansion. And the correlation between the predicted and observed cosmic abundances of hydrogen and helium was the major proof of the Big Bang Theory. And in the stellar evolution, the stellar nucleosynthesis is the process by which elements are formed within stars. And the star formation theory proposes that stars form due to the collapse of the dense regions of a molecular cloud. And stellar evolution is the process by which a star changes during its lifetime. So I have here things for you to check your understanding of after watching this video. And also this one, I want you to challenge yourself or try to answer this for you to have an idea. And this one also will help you to develop a critical thinking. Are nuclear fusion reactions of elements lighter than iron energy requiring or energy producing reactions? Why or why not? So these things are taken from Kuiper, and these are the resources from Kuiper. And for this class, for this lesson, I want you to answer your quiz in Kuiper. I want you to answer your quiz in Kuiper to be sent. Then just few reminders, clean your table in preparation for your next subject this afternoon, and wash your hands, sanitize your study area. Then join your next class 5 minutes before your actual time. And this is all for today, and stay safe and have a good day. And once again, this is teacher Kathy. Thank you for watching this video, and I hope you learned something.